We are going to go through and review for your quiz check tomorrow, and then you're actually going to have some time to go through and do some practice problems to make sure that you know what to do and you're ready to go for tomorrow's quiz check. So everything for this quiz check is all about quadratics, parabolas, intercepts, vertex, maximum, minimum, what direction it opens type stuff. So here's one type of example where we're just going to be identifying the different pieces of important information about a parabola. So first of all, when we look at this, right, does this parabola open up or down? And that's just a visual. We look at it, it looks like a U, so it is opening up, so we would select that. Okay, when it's asking us to find the X and Y intercept, we need to keep in mind that the X and Y intercept are where a graph crosses the X and or Y axis. Okay, so when I'm looking for the X intercepts, I'm looking for where the graph crosses the X axis. Now remember, the X axis is this, don't know what happened there. The X axis is this axis. Okay, so when we're looking at that, we want to know where it touches. So if I'm going to make this really fine here, it's sort of, apparently because I'm going from the side of my screen, I'm going to make it pretty small here. Okay, and we'll see that this touches the x-axis at this point here and at this point here, right? So we would just be naming those points. Okay, and that's at -1 and 3. So our x-intercept would be -1 and 3, right? We put a comma in between when there's more than one. Our y-axis is then our vertical axis. So I'm going to erase this stuff, and now I'm going to go to my y-axis. Okay, so my y-axis is my vertical axis. So I'm looking at this line, and I want to see where it crosses on the y. So it crosses right here. That's a little bit low, but right here. So we would name that point, which is 3. So we would say that our y-intercept is 3. Okay, we might have 2 x-intercepts. We might have 1 x-intercept. We might have no x-intercepts. But we almost always have 1 y-intercept, rarely 2. Okay, that would be something that's no longer looking at a quadratic. The vertex is where we see this where we see this have the top or low point. So this one opens upwards, so it has a low point. So we want to name this point at the very bottom of the parabola, right? So we're naming this like an ordered pair. So an ordered pair goes from the origin, right? It's over 1 and then 1, 2, 3, 4. So we have 1, -4. So that would be our vertex. Once we name our vertex, so even if it's asking you to find this axis of symmetry before you identify the vertex, always find the vertex first. Because if you found the vertex first, all you need to do is identify your x value of the vertex. Because remember, the axis of symmetry is x equals h. So in this problem, it would be x equals, and our h value or x coordinate is 1. Make sure you type in the x sign, make sure you type in equal. So you have to have the x equals for it to be the correct answer. Okay, so we're going to look at another one here. You'll have to do some graphing with quadratics. Okay, so let's say we want to graph this. If we want to graph x squared plus 10x plus 30, we're going to want to make a table. And we always want our vertex in the middle. What formula do we use to find our vertex? We should have said -b over 2a. So we're going to put that in the middle because our vertex is the middle of the parabola. So if we look up here at this problem, a equals 1, b equals 10, c equals 30. So if we do -b over 2a, I'm going to do -10 over 2 times 1. What will that get me? We should have -5, right? -10 divided by 2 is -5. We are then going to count up and down. So -5, -6, -7, -4, -3. What do we need to do to find each of the y values? We need to plug each of these x values in for x. Okay, so I'm going to say negative 7 squared plus 10 times negative 7 plus 30. And again, you can just do this in your calculator. Don't make any more work for yourself than you have to. Just let the calculator do the work for you. And we get out 9. Okay, and then I even just arrow up and change that those two negative 7s into negative 6s. And for our next one, we get out 6. Okay, then we're going to plug in negative 5. We get out 5. What should we get out for the negative 4? Okay, when we plug in negative 4, we better get out an answer of 6. If we don't get out an answer of 6, then we did something wrong. Okay, so when we plug in that 6, we need to, when we plug in negative 4 is what I meant. We should get out an answer of negative 6, okay? So if I plug in a negative 4, I'm just going to double check here. Make sure I didn't make any mistakes, which I do sometimes. We do get out 6. Right? Because it's always important that we have this nice symmetric look going on, which means when we plug in negative 3, what better we get out? We absolutely need to get out 9. Okay, then once we have our table completed, what is our next step to graphing this? We need to plot each of these points onto the coordinate plane. So I'm going to plot negative 7, positive 9. Okay, then I'm going to plot negative 6, positive 6. It's a really big point. Negative 5, positive 5. Negative 4, 6. Negative 3, 9. And here is our quadratic. Okay, so that's what we should be doing for the second problem in your review packet today. The third type of problem that you are going to see in your review packet today, okay, is dealing with finding the x-intercepts and the vertex for a parabola. So remember when we are looking at something with x and y intercepts or the parabola and we don't have the actual visual of it, if we think about a quadratic, right, if this is a coordinate plane and this is our parabola, the x-intercepts are also called the solutions. So to find the solutions, that's where we use the quadratic formula. So you might need to write this down to remind yourself, x-intercepts, we're using the quadratic formula. Okay, so the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and this problem tells us that a equals 1, b equals 2, and c equals negative 3. So we're going to start plugging these values in. X equals negative b, which is negative 2, plus or minus the square root of 2 squared, minus 4 times 1 times negative 3, all over 2 times 1. What step do we need to do next? We need to simplify everything underneath the square root. So you, again, don't make any more work for yourself than you have to. You're more than welcome to use your calculator to do it. Just make sure you're typing it in exactly how you see it. So when we simplify underneath the square root, we now have x equals negative 2 plus or minus the square root of 16 all over 2. Once we're here, we are going to take the square root of 16. So the square root of 16 is 4. Now that square root symbol is gone because I already used it. The square root of 16 is 4. No more square root left. And what is my next step going to be? Right? I now need to consider both options because I have a plus and a minus sign. Right? So I need a negative 2 plus 4 over 2. And I need a negative 2 minus 4 over 2. Okay, so we're going to calculate both of these values. So 4 plus negative 2 is 2 over 2, which gives me a 1. And a negative 2 minus 4 is a negative 6 over 2, which gives me a negative 3. Okay, this tells us that our x-intercepts are 1 and -3. Now, if that wasn't enough work, right, we are not done with this problem yet because it also wants to know the vertex. And to find the vertex, that's where we're doing the -b/2a. Okay, so this was like part 1. Part 2, I need to do the -b/2a. So in this case, I'll be doing -2, right, -b/2 times a, which is 1. So -2/2 is a -1. That means the x value in my vertex is 1. But a vertex is always an x and a y. So I now need to take this 1, right? And I need to plug it in for both of these x's. So now I'm going to say 1 squared plus 2 times 1 minus 3. Let's see, when we do that, we get an output of 0. So our vertex here would be 1, 0. So we would need both of those pieces, all of that work for this one problem alone. Okay, you are also going to have to do a problem dealing with the max and min. Okay, remember we determine if something has a max or a min, a maximum or a minimum, by deciding if the parabola opens up or if it opens down. And A is the value that determines that. So what does A equal in this example? A equals 2. Okay, so A is positive. So if A is positive, did we say that meant the parabola would open up, or will the parabola open down? This is a parabola that opens up. So if this parabola opens up, does it have a low point that we're going to call a minimum, or a high point that we're going to call a maximum? Right, this has a minimum, so we should be selecting minimum here. Now, to find the minimum, we need to find the vertex. That's what it's asking us to do. So to find the vertex, we said we're doing -b/2a. So in this situation, b is 20, so -20/2 times a, which we already said was 2. So -20 divided by 4, so -5. Does this -5 tell us what the x value is or what the y value is? This tells us the x value. Remember, the formula is x equals -b/2a, which means this -5 is the first number in our vertex, and it needs to go in the box that says x equals. Okay, to find out what the function is at its minimum, we then need to plug that value back in. So now I'm going to take that -5 and plug it back in, right? It's going in for both x's. And then I want you to pick up your calculator and plug these numbers in and tell me what value you get out. We should have got out -3, and that is the second value here, which means we have a -3 in our other box. So you're going to go through and complete your own assignment of this, which is going to be practice so that you're ready to go and good to go for your quiz check tomorrow.